Hi everyone. It was just 3 days ago. I stood there, facing a large crowd of journalists. I was wearing a work cap, a tracksuit, and a blazer, all at once. How did I ever end up in such a strange situation? Well, let's find out. It all started with a phone call back in November of 2017. I got a call from an unknown number, and a pleasant male voice said, "Alexei?" I said, "Yes." He said, "Alexei, we have a problem." I said, "Who are you?" He said, "I'm from the city of Emsk." I asked, "Where from?" He said, "The city of Emsk." I said I didn't know where that was. He said, "Nobody does, and that's our problem." "I'm calling from the city of Emsk, and I want you to find us an identity." I was taken aback. A small meeting took place inside me. Ravenclaw Aleksei Shipulin said, "That's an excellent task, worthy of an inquisitive mind." Slytherin Aleksei Shipulin said, "Dude, you can't even figure out your own identity, let alone a whole city." The Hufflepuff didn't understand what identity was. And the Gryffindor said, "Listen, if they called some random guy and asked him to find them an identity, then damn it, are you really going to chicken out and say no?" Of course I agreed, and that's why today I'm going to tell you about how we tried to find an identity and what visualization has to do with it. My name is, as I think I've already said 6 times, Aleksei Shipulin. I work in the social media industry, and I also perform social media research. So, what exactly do we mean by social network analysis? When individuals interact with one another, they establish meaningful connections. When there are many such people, these individual connections form an entire complex network. Once established, we can describe it not merely in a graphical sense, but in a rigorous mathematical way. By studying the unique characteristics of this network, we can make informed assumptions about how the people who are part of it behave. I specifically handle social networks like Facebook, VK, Twitter, and so on. But in principle, this applies to any networks that people form, to any communities, like phone calls, or the people who came together for Science Slam art. Actually, that's what I had to find out. What makes the city tick? The electronic city of Emsk. What electric dreams it sees, and what it's all about. What kind of people set the trends there, and what those trends are. But prior to my explanation of precisely how we accomplish this feat, let us delve a little more deeply into the subject of visualization, because the consistently recurring theme among all of the presenters today is indeed art, it is visualization, and I have also incorporated this very concept. And yes, indeed, visualization. I thank you. Just think about how much effort it took for me not to make this thing just bounce all over the screen, burning and engulfed in flames. Okay, I'm going to tell you more of a legend than a true story. I'll talk about how visualization came to be. As most scientists know, science isn't about rats with 3 belly buttons, explosions, or colorful solutions. It is primarily data, a huge, overwhelming amount of data, most often expressed in the form of numbers, in which scientists try to find correlations. Originally, the act of calculation was not separated from the process of visualization. A simple notch or a tied knot was the number. The more notches you had, the larger the number would be. It is all perfectly logical. Just like the bar charts you can create in Excel. But the problem was that the pieces of wood were too big, or rather, they were actually just too small. And it took a very long time to write a large number. And at some point, we invented digits. And that would be fine, except that notches are easy to work with. We have a natural grasp of physical size and shape, but numbers are really nothing more than abstract little squiggles. Who can truly say what they actually mean? And yet, they are remarkably effective. Instead of having to carve out 357 individual notches, you simply write down 3 digits in our numerical system. Other systems might differ, but this was truly the very first stage of what we call data compression. And up to a certain point, that was quite sufficient for us. But as the volume of data grew even more substantial, we needed to leverage entirely new capabilities to organize it all and store it somewhere within the actual bounds of our own understanding. Then we utilized another ability that humans possess from birth, namely to orient oneself, to perceive well and to navigate in space and to orient space. And we rearranged the numbers. That is how tables came to be. Tables are a highly effective way to condense information, where every value has two specific coordinates. Knowing them allows us to pinpoint exactly what that number represents. Tables have become incredibly popular tools. Scientists everywhere rely on tables. Most data is now stored in a table format. Tables have moved beyond the academic world and burst into our lives. You can find tables everywhere. Who among us doesn't dream of taking the route from Sosensky to the hospital to the cemetery? Well, that would be much more inconvenient if the schedule weren't in a table, but just as a list of time intervals for when the bus arrives. We would never make it to the cemetery if it weren't for tables. There are even more extravagant examples. Believe it or not, this is also a table in its own way. These are the monkey's paws. They are, in essence, a row and a column. If we put one paw on 4 and the other paw on 8, we get 32. It's the same principle, just wrapped in a more elegant, interesting form. You get it, right? The multiplication table. I don't know. Not everyone was lucky enough to be in science, right? Okay, tables are two-dimensional. We tried. We had more data, we tried to cram even more data into them and created a third dimension, but we ran into a problem. Most of the tools we worked with, such highly integrated environments as the paper we drew on and so on, are two-dimensional. Even modern displays and, say, a very powerful iPad are really no different from the tools we used to write with years ago. Back then, all we could ever manage to create was simple 2D projections for our visual representations. And that didn't work very well. But we started rotating 3D charts, or 3D tables, to get a better handle on them. And then it hit someone, damn it! People are actually great at perceiving movement, just amazing at it. We have also incorporated dynamic motion into our data charts. You will likely encounter this feature in various web or mobile applications. A vast number of modern apps feature a slider that you can move to change the position, and the chart value will update in real time. For example, this occurs quite regularly on popular weather websites and flight booking platforms. And that's where things got tricky, because people realized, man, there are tons of things, shapes, sizes, distances, that people perceive really well. Most people are good at perceiving colors and so on. But then there are numbers, which people don't perceive quite as well. They just don't have that, that popular phrase. They aren't intuitive. This part seems pretty intuitive. There's a big thing, there's a small thing, it seems clear. And yet, the actual information content of these things is, near zero. In a sense, we've gone back to tally marks. Yes, they create an illusion of understanding, but if they're just infographics for the sake of infographics, we're going to run into serious problems. What about social networks? Essentially, when Vasya adds Petya as a friend, not in the language of those pretty graphs we often see, but in the language of, let's say mathematics. It's just a table where there's a 1 at the intersection of Vasya's row and Petya's column, and in principle, that's clear and cool if we only have 4 people in our equation. Even if we organize one person's data into a structured table, mapping that individual, their friends, and all their connections, we end up with a massive 600 by 600 grid. Just looking at it, it's impossible to grasp anything. That is exactly when we must turn back to the power of visualization. This beauty here is a graph of one person and their 600 friends. It looks pretty straightforward. There are some guys here, some guys there, and they communicate well with each other. Over there are some outsiders that nobody likes, and right here in the center are the cool ginger folks. And all of this was built automatically. And you're like, man, I look at this, and I understand how everything is structured. There are 7 groups of people here. Everything is clear, easy. Actually, no, because this algorithm is a standard one that's built into CAPE. And the question arises, how accurately does it actually divide people into these clusters, these groups? If we take any other algorithm, a standard one, we'll find that no, we can divide people into a different number of clusters. And while the main trends might remain the same, people on the periphery of these clusters, for example, might get lost. There are issues with that. So, what do? We go back and revert to the tables to validate, that is, to confirm, that this graph and these groups make any sense at all. We download additional information. We mostly work with technical aspects. Since we deal with virtual social networks, for example, we download all the posts and look at how similarly people in one such cluster write to each other and how separated they are from people in other clusters. What about Emsk? Let's get back to Emsk. To work with Emsk, we downloaded all the residents of the city of Emsk and all their vContact contacts. We downloaded all their interactions, how they communicate with each other, what public comments they leave, who is friends with whom, who likes whose posts, and who reposts whom. Based on all this information, we ended up with a huge table, essentially a massive prototype of a graph, containing, well, several tens of thousands of people. And with a table that huge, you can't make sense of anything. If we had built a graph like that, you wouldn't understand it either. It would just be a mess of dots. And we realized that our main task was to find cool people from there. And since we saw the patterns, how people repost information, how they like each other's posts, we were able to build entire chains. Let's say Vasya reposts Petya, Petya reposts someone else, and so on. Based on this, we were able to find the top guys who, in essence, shape the entire identity. Well, not the entire identity. I probably went too far there, but they are responsible for the entire information landscape of Emsk. They are responsible for either they generate the content themselves and people enjoy reading it, or they happily repost content. And other people are happy about what they've reposted. So we built this awesome thing, which is fully interactive and written in the super cool D3.js. If you are a designer, you know just how incredibly hard that really is. You can move it, you can hover your mouse over it and see people's names, but I've blurred them out. And what's more, by clicking on one of these nodes, you can even go to their page. As you can see, there are red dots here, remember them. These are the top 8 people, it seems, who are essentially responsible for, or rather, the ones around whom all other social interactions in this small town of Emsk revolve. Furthermore, we also looked at what they write about and what they most often associate their city with. What kind of associations do they have? We first found positive associations, but realized, damn it, we can't limit research to just those. We must find the negative ones too. We incorporated negative associations and compiled them into a report. Then we realized there's self-identity versus external identity. We distinguished how locals write about their city versus outsiders, even those who visited. We found that locals write more about children and sports, while outsiders focus on tourism and nature. And what was most important of all, we then considered, what if we were to make an attempt to discover what the fundamental life values and principles of the inhabitants of the city of Emsk actually happen to be? And to find that out, we again used an algorithm that can find associations that were most frequently mentioned in the texts of Emsk residents. And we took the most, significant words: life, death, birth, old age, family. And we decided to find out, how thoughts think. And it turned out that it seems the identity of Emsk has been found, because we compiled all this into a report and sent it to the person I spoke with on the phone. He processed it and discussed it with his team. He called back. Aleksei, about that chart you showed at the start, is this the list of the most active cool people in MSK responsible for all the action? I said, well, we assume that's them, yeah. He was like, we want to hold a forum on the self-identity of Emsk. What if we invited all those people? I said, great idea. He said, well, great, then you'll speak in front of them and present the results of your research. I had a quick internal meeting with myself. Aleksei Shipulin Pushinduret said, a talk show in Emsk. Pack your bags, we're going, of course. Aleksei Shipulin the Gryffindor said, wait, hold on a second. We want to go to a talk show in a city where the nearest connotations are death and ACAB, right? Hufflepuff also said that he wouldn't go, and the Slytherin said, okay, we'll go. But to stay in one piece, we are going to show up wearing our absolute most gangster-style outfit. I went ahead and performed. Actually, it was really interesting. A bunch of locals from the regional center gathered there. Some were giving pompous speeches. The standard bureaucratic kind. Others were talking about what Emsk is most associated with, what its symbol is. Is it a bear or a moose or a squirrel? They were discussing things like that. Then I really liked that they were discussing what festivals should be held in Emsk. There was a fish soup festival. They were discussing how the fish soup festival had outgrown itself and that they should hold a fish feast instead. Well, I suppose it's something like that. But the most important thing is something else. The most important thing is something else. At some point, it was unexpected, I hadn't been told about it, the show's host called the people I had found onto the stage. Those very red dots. People who live in Emsk, who work there, came out and shared their stories. Many decades have passed since a man first arrived in Emsk, and he decided to make this place his home. He is a professional photographer by trade. At first, he began capturing images for his own satisfaction. But eventually, he started sharing his work on the internet. He became incredibly popular, and soon enough, everyone in town wanted him to document the daily life of our city. We asked him who mainly looks at his photos. He said, well, the locals, of course. But he described the audience, for example, people who left Emsk a long time ago in search of a better life in Moscow, St. Petersburg, and so on. And they look at his albums and photos just to remember their hometown, to feel that sense of identity. I think I can probably use the word with them here. There was this particular woman who, she seemed really quite shy, and when she finally got up on stage, the host came over to her and asked what she did, and she just said, "Snow." She handed back the microphone and sat down. The host ran after her, asking, "What exactly do you mean by snow?" And she just looked at him and said, "Well, you know, snow." "You don't know snow?" He's like, "What do you mean?" She's like, "Snow, the material. Look, those sculptures. That's my job, working with snow." Well, and all of these people, this was already well into the forum proceedings. They were warmly welcomed. They were very strongly supported. They are deeply connected to our history. They were supported by the adults, or a young girl who worked with the snow. For the children who came to this forum, and there were many of them, they were ecstatic, cheering for her. And of course, I told them everything we'd found about identity, all those associations and all that. But for me, something else was the most important. I spend my time sitting here at my screen, staring at endless gray and red dots, complex formulas, and dense data tables. That's my whole routine. I just package it up and send it to those who keep asking me to plot those points. And that was the exact moment when I witnessed how these points, some truly remarkable local heroes who work to foster this sense of unity, I watched as they took to the stage to share their own personal stories. And so, as I bring these remarks to a close, if the process of visualization is something that truly helps to make our data, your own data, or indeed any data far more understandable and clear, then these very real people and their deeply personal stories have effectively become a living visualization for me. I would like to thank you all for your time.